let's let biology do its thing. But before we were kind of limiting it with the existing infrastructure, and now we've really unlocked and unleashed the potential of these microbes.
Hey, Carl, how's it going?
Iram, you missed out on a great event. I hung out with a bunch of biotech investors last night at a coffee shop listening to ambient music.
Wow, that's a different experience from the networking at a bar, loud music everywhere, people talking over maybe some music from the 90s, now a Japanese listening experience. That's cool. What did you guys talk about? What was it like?
We listened to an album called Sakura by Susumu Yokota, who was a Japanese techno and ambient music producer. And you're not supposed to talk while you listen. Sakura is a 4-side album. So once I got to side D, I moved myself away from the crowd so I could actually have a conversation with one of the investors away from the crowd. And what's interesting is the space is set up so that you can have a bunch of people grouped in one part of the room because you've got these two really incredible speakers. But then you can move to the other end of the coffee shop and have a good conversation. And the music is still equally loud, but you at least can have the conversation. And then once the D side was played, everybody was able to talk. It was an interesting experience to sit around. I've gone to a lot of meditation, group meditations where you sit around like that, but never where you're listening to music. So that was fun.
Only in Brooklyn can you have those experiences.
Apparently, these listening bars are a big thing in Japan, jazz listening bars, and there's a couple that are legendary. And you, unfortunately, couldn't make it because you were sick. What the hell happened?
Yeah, so I had gone to an indoor water park for my son's birthday. And I think that's what did it, Carl. I mean, they have hundreds of people in this indoor wet environment and it's humid. I'm sure those kids are not rushing to the bathroom when they have to go. They're already in a wet environment. I mean, anyway, like for me, like I'm complaining about it now, but it was fun experience, I would say, like just going down water slides and just being with my son and doing all the fun things you do at a water park. Really cool. It was at the American Dream Mall. So I think it is the largest indoor water park. It was like 30 degrees outside. So it's a fun little getaway in the winter. But I had to pay for it. Yeah, I paid the price. I missed out on that fun event that he went to. But here I am. I might sound a little nasally, but I'm trudging through this. I don't have a fever. I feel good.
Good. So one of the things that we wanted to let our audience is that Synonym has changed their name to Roebling. You had a hint of this. I kind of had a hint of it. I thought that Roebling was just going to be one of their products, but we couldn't talk about it on the interview.
Yes. We had this interview with Joshua just a few episodes ago, and we knew that they were going to change their name, but we had to bite our lip, make sure we didn't say anything because, of course, you have to have a formal launch, and they have done that. So everyone updated their LinkedIns. And wow, I mean, if you take a look at Roebling's demo video, how they're using AI to project plan industrial biomanufacturing, like, is incredible. Incredibly fast, incredibly thorough, and very simple to use. Just LLMs, just writing, just typing in prompts, asking questions, having the AI think critically on how to create process for biomanufacturing and other manufacturing. It doesn't have to be biomanufacturing. You know, they could take a wider lens now that they have this tool in place. But let's think about that a little bit because Synonym has had a great exposure to the biotech industry. They have created other tools that companies have used, especially startup companies, on how to first identify where there's fermentation capacity around the world. So people were able to navigate that, interact with that piece of software, asking what type of things they need to run their biomanufacturing processes on site. So that's one tool that they had running, open, free. I think, actually, I don't know if it was free, but it was around for a few years for anyone to use. And then they also had another software. Capacitor was for the fermentation capacity, and Scalar was for their techno-economic analysis or their life cycle analysis software that people would put in all of their processes to determine, is there an economic value to be had with their process? How much would it cost to make their products, and what is the environmental or health impact of their products? So Very cool that they had all of this data. I'm curious to learn if that has informed their new piece of software, which under the Roebling umbrella helps to create these biomanufacturing processes.
Yeah, I think what we have to do is we have to get both Edward and Joshua on to talk about this in a couple of weeks or months so that we can get a better picture of what Roebling is really focused on. But these tools are incredible, and I'd like to go behind the scenes and kick the tires a little bit to find out exactly what they've learned in their few years of existence.
Yes, yep, exactly. And again, maybe it's something we like have them do a live demo and we're like, hey, look, how do you manufacture food dye? Let's do it right now live. And then people can, it's really great to see demos. I mean, pitch decks, okay, get an idea, but there's nothing like seeing the actual product. So very cool.
Especially in IRL, in real life.
Yes, that's the best.
You've experienced this where you've had to do demos and you've been at a number of startups, doing these things. Can you talk about your experience?
Yes, yeah. I've worked at a variety of startups. Obviously, the startups that are software-based or SaaS platforms are easier to demo. I'm not a programmer, but always worked with a CTO. And to be able to create software, obviously now it's super easy. Back in the day, it was a little bit harder, but it's easier to demo. I had worked at a nanotechnology startup, which was the first startup that I actually joined in my experience. And it was about 14, 15 years ago. What they did was they converted waste carbon emissions into carbon nanotubes.
I remember that.
Yeah. And it was like ahead of its time. Now using waste gas is much more common, which is the topic of today's interview. But back in the day, it was very hard to wrap your head around, and it still is. Now we have
carbon
more
waste. What is that?
Yeah, carbon gas waste, like waste gases.
Carbon gas waste.
Yeah, it's like, what is that? How do you compress it? And the company I worked with, at first it was called Damascus Fortune, then it was called Carbon Continuum. I did a lot of the BD aspect of it. I don't have a background in nanotechnology. It was more my background's in chemistry. But it was building this reactor in order to pull the waste gases into the reactor. It was able to use this, it's called like carbon vapor deposition, is like the process to be able to make carbon nanotubes from carbon emissions. And there's a variety of different types of carbon nanotubes depending on the purity of the gases. And there's hyper pure carbon fibers that you could use for like semiconductors and electronics. Then there's ones that are called multi-walled carbon nanotubes that can be used to make materials. And that was insane. That was my first startup experience, but it was amazing. It really opened doors to a lot of opportunities. That's when I first started participating in accelerator programs, pitching to investors. So I had to pitch this company to investors. I pitched on stage in Barcelona. So I did a little bit of Spanish to speak to the audience. It was bizarre. But that was an introduction into being able to look at how to use waste gases and make valuable products, which is the topic of today's interview. And we're interviewing Sophia Xu of CarbonBridge.
I'm super excited about this interview because we've had a number of people come on and talk about how they feed microbes with gas. That includes Cemvita, Lanzatech, Mango Materials, and Industrial Microbes. Each one of those companies has a different take on taking methane gas or carbon-containing gas and turning it into a valuable material. And so now we'll hear from Sophia Xu and her experience with her company, CarbonBridge. Sophia Xu of CarbonBridge, we are so happy to have you on the Grow Everything podcast.
Thank you so much. Really appreciate the opportunity.
So you've had a super interesting path. You were publishing cancer research when you were a teenager. You turned down medical school and you ended up co-founding CarbonBridge. That's an extraordinary path. What was a moment that made you choose building a climate biotech over practicing medicine?
Yeah, I mean, when you put it like that, it does sound very extraordinary. But I will say, as the person going through it, it definitely did not feel like that at the time. What I would say about moving towards climate technologies, I think that I was actually always inclined to be in this space. Of course, my parents were very much focused on med school, the kind of stability, and while I definitely respected that quite a bit, and I do think human biology is very, very fascinating, I think climate impact comes with a massive health impact as well, especially if you're targeting areas like seaports, for example, that are heavily polluted, but also extremely marginalized in terms of their population. And so you kind of see a disproportionate health equity kind of impact. And so it felt really round together. And I think I've seen it quite a bit throughout my inclinations and the things that I like to research. So it felt very full circle when it came time to really jump ship, though it was definitely not easy making decisions.
Yeah, that is incredible. I mean, ultimately at the core of everything has been biology, right? How do you leverage biology as a tool? But there's this belief that biology isn't just a tool. It's a whole new industrial platform. I'm sure this resonates with you. And as someone who is engineering microbes to process waste gases, which I'm so excited for you to talk more about, do you feel that biology is starting to rewrite how heavy industry works?
Absolutely. I think this biomanufacturing, this idea that biology should not be constrained to biopharma, which I know is what Grow Everything is really focused on. I think that is a really good aspect. I do believe that microbes, my co-founder says this all the time, there's a bug for everything. Microbes are able to produce a wide variety of things, everything from your commodities, everyday fuels and chemicals, to these higher margin, higher value products. So I think what we're really going to see is not just the genetic engineering component of these microbes, but also the infrastructure, which is really where CarbonBridge falls into. So more of like an interdisciplinary approach to biology and really bringing the future of biomanufacturing forward.
Yeah, that really makes sense. I mean, we're going to dive into the technology, but could you help our listeners visualize CarbonBridge? If someone stood next to one of your systems, what would they see happening? Gas in, gas out. What is it?
Yeah, so what you would see is this bioreactor, but our bioreactor doesn't really look like your typical fermenter that you would use to make wine or beer. Instead, it's almost this like planar, flat, modular system. So think of it as right now the size of your average MacBook. And you would have these reactors stacked on top of each other. So maybe 3 MacBooks stacked on top. And then you've got inputs where you got gas flowing in. Occasionally you have liquid flowing in, and then on the output, you get liquid coming out. And that can be your fuel, your chemical, whatever product of choice. But essentially, you've got this magic box where the microbes are operating, doing their things that they've been doing in nature for millennia, and they're making some really interesting things for us.
Oh my gosh, I love that. I actually had an opportunity to see your modular bioreactor MacBook-like device when I was at IndieBio Beta. I don't know if it was last year or the year before, but one of your co-founders, Manu.
Yes, yeah. Probably last year.
Yeah. So he was on stage and he brought it on stage and I was like, wait, that's a bioreactor? I mean, it's so like that could be in my house, like it's something that could be like in the corner of my my apartment and making things for me. And I was like, this is really unbelievable. But maybe like thinking a little too, I don't know, maybe there's more to it than just those. But is that it? Is it just those MacBook size devices?
Yeah, I mean that is the essential magic box. I would say there's a lot of things around it, right? Mm-hmm. So all the fluid controls, there is an AI kind of software layer, so we can control what goes in and out and tune it to productivity, but that's essentially it. I mean, oh my gosh. It's one of our favorite party tricks, networking tricks to, be like, we've got a bioreactor in a backpack.
Oh my God.
That's amazing.
Yes,
amazing.
I love it. So you mentioned a little bit about how it works. You mentioned that there's different controls, and in traditional chemical engineering, control is everything. But biology is very unpredictable, and unpredictability is like built into biology. So how do you navigate the tension that a scientist feels when they're designing with living systems to perform reliably at scale?
Yeah, I think there's multiple layers to that. I would 100% agree, and we're actually working with a non-model organism, so not your typical E. coli or yeast. And so there's a lot that we don't know about the microbes. And of course, everything is living, so there's a lot of uncertainty. When we get this question, though, we also always point to wine and beer and how we've kind of scaled and perfected that process over thousands of years. So we know biology can scale. You do need the information around it. Unlike some other biotech companies, because we don't, and it's a whole research project to know all the internal mechanisms of what's going on inside the microbe, we focus on everything around it. And so we kind of treat this microbe as this black box, but we want to make sure we tune our inputs and our outputs very carefully so we can make sure that this entire system scales. I will also add, kind of from a chemical engineering perspective, your traditional fermenters are massive vats, right? They're really large tanks. And the way that we scale is we go from, 1 liter to 10 liters to 100 liters. But really what is key to scaling is how do you control the local microbial environment? Like if you're a little microbe, it's like, what do you see? You see the pH, you see the temperature, you see the gases, right? Things like that. And going from that kind of 10x scale in these increasingly larger tanks, it's really, really difficult to both model and control that local microbial environment. But as you mentioned, Iram, our kind of MacBook little devices, they're scalable simply by stacking, right? So we just have to control that tiny kind of internal cavity that each MacBook has and then simply stack because it's so modular. So scaling for us is a lot easier than traditional biotechnology, I would say.
And Sophia, is it proprietary what non-model organism you guys are using?
Oh, not at all. We're using a methanotroph. These are little bacteria that like to eat methane and oxygen and can convert it into multiple different things. But what we care about is methanol, which is kind of a C1 alcohol building block to multiple different processes, but also is fuel for the maritime shipping industry.
I want to just follow up on that. You talked about stacking these MacBook-like bioreactors on top of each other. You could probably use just one, but what's the biggest stack you guys have ever done?
That's a great question. Right now, we've done about 3 stacks on top of each other. That corresponds to about an 80x increase in scale from what we started. So that probably took us maybe about 3 months. So we've been very successful in scaling because, again, the productivities have really held up. But we're really excited to just stack more and more. But there's kind of we need to introduce some more automated valves. A lot of control systems now is really where we're at.
Yeah, I mean, one of the things about you guys is about CarbonBridge is that you claim this massive performance increase while offering a green discount. And that's a pretty bold promise. Where did you realize sustainability and economics didn't have to be trade-offs?
Yeah, I mean, again, kind of going back to the theme that everyone traditionally thinks that biology has to make some extremely high value, like pharmaceutical drugs or other products like that. We wanted to target commodities because that has the greatest impact initially. And so to do something with commodities, but also to make sure that you can compete economically without subsidies or credits means you have to have a very scrutinized focus on both your capex and your opex. So traditionally, renewable methods to make methanol, for example, the thermocatalytic methods, they utilize extremely high energy because they have extremely high temperatures and high pressures. I mean, we're talking about like 1,000 degrees Celsius. And basically, they take these renewable inputs, which cost money. They have a very expensive process because everything from the steel that they use has to accommodate this extreme, pressure and temperature. So that's extremely high capex. And then also the electricity they need to be able to run these processes at that energy. So they're never able to compete. And then we have to talk about subsidies, credits, charities, things like that. For us, biology really was the game changer, right? Like these microbes, they've got enzymes that can do these things like methane to methanol in a single step at 30 degrees Celsius and at ambient pressure, right? Biology is happening around us at all times, which is really what's amazing about these biocatalytic systems. And then on top of that, we're taking waste. So it's really about truly leveraging the capability of the microbe, making sure we have an infrastructure that doesn't add complexity to that, and then being able to compete on that method.
Yeah, amazing. I love the fact that you just said doesn't add complexity, because there's been a lot of solutions that, because we didn't have as much knowledge, that are over-engineered. So to be able to like allow biology to do its thing in a semi-controlled environment is like, it's where it's at. I mean, I love the way that you're thinking, and I hope more companies think this way, because sometimes over-engineering, it costs more money, like you're saying, with, whether it's energy inputs or other types of feedstock, other types of controls that are necessary.
Absolutely.
Yeah. And so we're talking about, going from lab scale to more industrial relevance, and to talk about stacking the three of those MacBook. We need to come up with a name. Is there a name for it, the bioreactor?
We call them notebooks, essentially, because they are actually sized like A4, A5 type of thing.
Okay, so stacking the notebooks, we're up to 3. That's an 80x improvement in performance. Can you provide some more numbers behind that? Like, what does that look like in terms of output relevant to traditional methods? I'm curious about that. And then another part of this question is what has been the hardest part when you're taking that leap, scaling up? Is it scientific? Is it emotional? Is it operational to go from lab to a real infrastructure?
Yeah, so I will say we are obviously not at the full deployment of real infrastructure, though we are expecting to hit that quite soon with some exciting developments probably later this year and early next year. But in terms of improvement, to your very first question, we're about 80% more energy efficient. And energy efficiency is calculated in many different ways, especially for fuels. It can be what's the heating value that you put in, and what's the heating value you come out because you burn up fuels, right? It can also be what is your electricity input that you get in versus the energy that you get out. So depending on how you calculate it, we're probably around 80% more energy efficient than compared to traditional methods. Compared to bioconversion methods, and we're benchmarking everything right now on methane to methanol. Mm-hmm. But I will note, if you put a new microbe in our system, that could perform very differently. But benchmarking on methane to methanol, our microbes are operating about 500% more productive than even genetically modified microbes.
Wow.
Right now, we're using fully wild type. And our whole thesis, like you were saying earlier, is that, nature has really evolved these pathways, let's let biology do its thing. But before, we were kind of limiting it with the existing infrastructure, and now we've really unlocked and unleashed the potential of these microbes. So there are some more technical challenges on its way, but what we have proven is the productivity of each microbe has increased significantly, and we don't think we've hit the limit on that yet. We've proved that scaling is a lot easier because it's almost a linear scaling, just add more surface area, essentially. Mm-hmm. And then the next thing that we have to work on is some microbe density type of things. A little more technical, but it's a very interesting kind of 3-box problem for us.
Yeah, I just wanted to add that, me imagining this, and I'm sure this is what other people are thinking with the notebooks, is just a server farm, just being able to have these notebooks stacked on top of each other, producing what you need. And then maybe it doesn't have to be that big, right? This is another way of thinking is all right, you have a server farm that's located in one place and it's massive and it has to distribute, versus perhaps, we love talking about distributed manufacturing, have smaller bioreactor locations to produce something specific, or it could change depending on how people want to use it locally. We had a guest on, Gabe Tavas of Symmetry Wood, and he talked about fab cities and how you're able to make things just locally that you need versus having to rely on things shipped around the world, rely on, volatile pricing. I mean, I'm feeling it in the grocery stores and other locations that things are getting really expensive. I'm why are things how do we get this back under control? And it just seems like, having things locally or regionally could help with that. So
yes, absolutely. I love that perspective because we also approached it from a similar idea, which is one, the feedstocks that are available are often a lot smaller. You would never build a refinery on a hog farm, right? It's just, you couldn't justify that $1 billion infrastructure investment. But for us, it's you stack more, you stack less. And so now we really are talking about local supply chains, distributed manufacturing, everything that you're saying is really resonant. And then I think the second thing that also you mentioned, which was really important for us, is this idea that you can switch products, almost like a reconfigurability, because you need that flexibility in terms of manufacturing, and you want to make sure you put your CapEx, you put your steel to work, right? It's not you've only got one plant that can only make one thing. And for us, it's well, you swap out your microbe, right? And then you can make different products. And we're really working with researchers that are developing a bunch of different pathways, and they will get money for their pathway. They can license their pathway out. We've got the servers, right, that these microbes operate on, and then we can make a bunch of different products together.
Wow.
Wow, that's such a brilliant way to localize and customize the CarbonBridge notebooks. Give us some examples of where these would be deployed. Like I could imagine I've got a dairy farm producing a fair amount of methane. I'm pulling it away from the cows and I'm driving it into a server farm, if we're going to call it that. But give us some examples of what deployment looks like.
Yeah, so essentially any waste gases. So we operate in the gas fermentation space. So if you're doing anything with sugars, we're probably not your best bet. That being said, if it is an aerobic process, like it's oxygen limited, we can also play there. In terms of actual places, you would think like a hog farm, dairy farms, wastewater treatment facilities, they're generating a ton of biogas. Even breweries, they have a 100% CO2 that's coming out. In agriculture, wineries, they're also generating a ton of CO2, but that's seasonal. So you have a fluctuation in availability of feedstock. And then, of course, landfills. So just typical waste sources. We are very much looking into partnering for degradation of lignocellulosic waste. So like solid biomass and then generating gases from that and then running it into a reactor. So there's kind of different Lego blocks that we can play with. That's really interesting.
And you guys have been supported by ARPA-E, IndieBio, and SOSV. You've seen both public and private climate funding up close. What do you think funders still misunderstand about scaling climate biotech?
I think that there's a lot of misconceptions. I would say the biggest concern, and probably still an accurate concern, is risk. And I think just the way that the geopolitical, economic perspectives are developing, people are willing to take less bets and less risk. And, there's obviously more attractive technologies that will provide a faster return for venture capitalists, as well as I would say the government is maybe less susceptible to this, but we're seeing changes in that area too. So I wish that people would take more bets. We're only here because SOSV took an early bet on us, because ARPA-E, our program director, was thinking that we were literally crazy. He told us we were crazy, but they're like, if they can make this work, this is game changing. And so I do think we're going to have new models of capital investment. I hope it comes quicker, because kind of the traditional methods, it does take longer 100% than say an AI company, but the impact and the potential return can also be a lot larger too.
Yeah, I love that you pointed out the different funding models. It's something that we've been thinking and talking about throughout the podcast, but also our work at Messaging Lab, because we talk to a lot of biotech founders, and biotech isn't necessarily AI software, right? It's a complete opposite almost. And so maybe something more predictable, like creating software and seeing how it operates, and you're able to test it and see how it works. It's easier to be venture-backed versus biological solutions. And what does that look like? What does alternative funding look like? So that kind of leads me to like this intermediary question about it, or a follow-up question is, you're making methanol or you're making different fuels for the shipping industry, right?
Great question. We actually sell bioreactors, but we're proving out our bioreactor through the methane to methanol process.
Okay, so you're selling bioreactors. Then like who have you like soft circled? Who could be potential buyers of bioreactors? And I'm asking that because we always think of like in the end, when you're selling something to a customer, that's the end value to the customer. I mean, and there's an exchange of they give you money, you're giving them a solution. So we think of them, they could be like strategic investors, or maybe, they buy the bioreactors on a wait list, and then after you develop it more, they can get it. So can you share like who would be a potential buyer of the bioreactors?
Yeah, so we've actually sold 2 bioreactors already. These are the R&D scale, but they were to a national lab and another kind of government research entity. The first one is helping us develop a process, an aerobic process, to go from waste agricultural oil to biosurfactants, which are kind of ingredients in hair care, but also lubricants, antibiotics, even pesticides. And then the second one is using our reactor to basically screen a bunch of microbes and see which ones are performant. So that way they can go from CO2 and hydrogen to XYZ product. So again, it's very much a platform play. We love working with researchers because the way that we see it is that if they develop a pathway on our bioreactor platform, they're kind of locked into our system, and then we grow together. And it's almost like, this is kind of a really unique way of thinking it, but of like an app store, essentially, or a pet store.
Yeah, I was thinking
where Right, where researchers can license out their pathway that they've developed because they love working with their microbes and they've worked with it for 5-10 plus years. They put it into our, our online website, whatever it is. And then some customer will come to us and they're like, we want to make this product. And we say, perfect. And we've got the bug that the researcher provided. We've got our reactor and we come together. So it's almost like a GPU kind of NVIDIA system for biotech that we're really interested in. But yeah, that's what we're doing in terms of selling. But those are kind of the reactor kind of R&D scale. And of course, on the larger scale, we do have an LOI with Norwegian Cruise Lines, and they want a ton of renewable methanol. But again, we don't sell the end product, so we have to find a project developer who would buy our reactors, sell the methanol, things like that. So you have a wide variety of customers, but essentially we've got 3 scales of reactors. We've got an R&D scale, we've got like a pilot scale, and then we've got, commercial 40-foot container footprint kind of scale.
Yeah.
Amazing. I could see some really interesting and innovative business models developing based on all of what you just said. It's not just the microbes or the notebooks. There's other business models that can be built around that. So that's super exciting.
Absolutely. Thank you.
When it comes to climate, a lot of solutions focus on carbon removal, and you guys are focusing on converting waste gases into something valuable, something useful. How do you think about performance, impact, and urgency when designing systems for a warming planet?
Yeah, so carbon removal is great and there's a place for that. But for us, maximum impact is not only taking waste carbon, but replacing fossil molecules or displacing fossil molecules by making a renewable product. We don't think that we'll be able to make everything, although we're working with more and more researchers, and I'm sure they're going to develop some really interesting microbial pathways. But if you can even just target 10 building block molecules that feed into multiple different processes, that is a massive, massive impact. And so we started with methanol, a C1 alcohol, right? You can do some C2 products, maybe even C3s, but things that, it's almost like a bowling pin. You hit one thing and you've hit a bunch of other things, right? So that's the way that we're looking at it. I do think that there's an urgent need to replace these kind of key molecules as quickly as we can. I know there's also an urgent push to electrify everything, but I don't think that that is physically possible especially for something like heavy transportation. So it is a rush to move forward. I think we are making progress, but again, more capital, more partners, more support is always helpful.
Yeah, I love that because this idea of like conversion, right? We think of like the circular economy, right? And you talked about how waste of fermentation process is CO2, and you could take that CO2 and make it into something else. Like there's no waste, which is how Earth and life and this planet works. There really is technically no waste. Waste is a man-made thing. Everything's used. And I just love that we talk about fermentation a lot here. I mean, obviously you're doing gas fermentation, but there's still another level that can be used to make value. Like there is really like no end. So it's just this beautiful narrative about continuing to convert something and, rebuilding products on a molecular level, which we love talking about too.
Exactly. And we're just here to speed that process up and, take a cut away from the microbes. The microbes are already making it for themselves, but we're like, that's a useful fuel for us. Let's take a cut,
Yeah, let's take a cut.
Yeah.
It is like we very much believe to work with nature, leverage nature.
Absolutely, absolutely. So let's do a little bit of visioneering, okay? So looking a decade ahead, what do you hope platforms like CarbonBridge, what do you envision that they do for us in everyday life? What, you're talking about fuels, materials, chemicals. What do you think beyond that it could help us with?
Yeah, so I personally also think that we are on the cusp of kind of this biotechnology revolution, right? It's been said also for a while, but we want to make sure that we increase reproducibility of biology. So this idea of a app store, pet store, it's like you've got this system that's locked in, right? And then technically another researcher could say, hey, I want to start working on this microbe and modify it. And they can get the full kind of software, they can get the microbes, there's a material transfer agreement, and they get it into their lab, and hopefully we can continuously build on each other's work. And so we're trying to hope that, this will increase the amount of research in this type of field. Like, let's really discover everything that these microbes can do, not just E. coli, not just yeast, not just your, microalgae farms. There's a whole range of different things. Let's incentivize researchers because they can now license their microbial pathways and they can have, some revenue shares. And let's just really boost up this industry as a whole, because I think there's a lot to be reaped from it. And I'm sure, Grow Everything also agrees with that.
Definitely. I mean, that is what we talk about on almost every episode. So we're going to move into the quick fire section of this interview. Iram and I will alternate questions, and hopefully we'll try to get you to answer briefly. And what we found is that this is a very fun part of these interviews. So, Sophia, what's harder to explain at a dinner party, climate, biotech, or AI?
Climate biotech. 100%. I think it does require, I think AI has also infiltrated our systems quite a bit, so people kind of know what's going on.
Yeah,
absolutely. Okay, so one climate myth you wish would disappear forever.
I think I talked about this a little bit earlier, but electrifying everything. There's a push, but if you just kind of look at the world and the infrastructure that we have, it's not built for electrical everything. So we need alternative solutions.
What's the biggest misconception people have about gas fermentation?
That you need to use bubbles. I mean, this whole idea that microbes have to be cultured in liquids and all that. Microbes love gases, unless they were isolated in the deep pits of an ocean, like they likely have some access to gas in soil and rivers, whatever it is. So there are new ways to cultivate microbes. You don't have to have everything in a massive liquid tank.
Amazing. Okay. All right. So one climate solution you're deeply skeptical of?
Hydrogen. I would say that there is a use case for hydrogen, but if there's any storage or transportation of it, eliminate, delete.
Okay.
Awesome.
All right. Finish the sentence. The future of industry will be built by
those who are willing to actually build it. And in particular, interdisciplinary teams.
Amazing.
Woo! Awesome. Oh my gosh. So well said. I really enjoyed this episode with you. I mean, I knew of CarbonBridge. Of course, I've got to give a shout out to Ellen Jorgensen, who's been on the podcast a couple times. Big fans of hers. And she's a part of your team. So I wanted to give a shout out to her. And we've learned about CarbonBridge and then how it's been progressing over the years. And we cannot wait as things scale up. We'll have to have you back on. Ellen, Manu, maybe the whole team, have a chit chat, maybe go behind the scenes. But there's a lot that we want to continue learning about CarbonBridge.
No, thank you so much. Really appreciate everything that you guys are doing at Grow Everything. I think it's a really important mission. Also going to shout out my team, in particular my co-founder Manu. He's a real genius. So it'd be great to have him on the podcast too at some point.
Awesome. Well, thank you so much for coming on Grow Everything, Sophia. Look forward to talking to you soon.
Yes, thank you. Thank you guys again. All right.
Yay.
Hey, this episode is sponsored by Messaging Lab. At Messaging Lab, we translate complex science and economics into compelling business narratives. And we have done so for the most successful biotech-forward companies across pharma, agriculture, personal care and beauty, materials, and the list goes on. We're here to make sure your ideas not only get heard, but resonate with your audience. So if it's time to amplify your company's voice and elevate your business, visit us at messaginglab.com. Let's grow.
Iram, what was your take on that interview with Sophia?
Oh my goodness, Carl. Like when you and I finished interviewing Sophia, we were like, blown away. We had so many ideas like, oh, well, we could put those notebooks over here and we can connect it to this fermentation tank and do. It was so inspiring and refreshing to see a different type of design when it comes to bioreactors and how they can be used first modularly, taking up less space, and to be used for different types of products to be made. I want to talk to Sophia and her team, Manu, obviously Ellen, of course, and be like, what can we do? Let's do something. Like products like CarbonBridge is making, like their notebooks that they're making, that enable more people to use gas fermentation to make things. So I'm just very excited. What about you? What did you take away from that interview?
I was spinning, in our conversation afterwards, I was spinning business models. I love that Sophia said, there's a bug for everything. Our listeners should go back and listen to our interview with Neely Ostroff of Cultivarium, because Cultivarium is focused on making non-model organisms accessible. And I think what Sophia is doing, having an app store where scientists could post their microbes and make them available so they could be put into these notebooks is an incredible opportunity and a different kind of business models. So for me, I kept thinking, what's the business model, or what are the multiple business models that CarbonBridge can create, not just based on, selling and or renting the notebooks, but what does that enable? And then, as I mentioned in the intro, we have had a number of other companies come on, talk about gas fermentation. How do they work together? How do they complement each other? I think there's a lot of synergy there, and I think it's very exciting.
Yeah, I could just imagine they're calling them notebooks. We all have notebooks, right? We all have our MacBook, or I don't know what other computers are out there.
Yeah. ThinkPads.
Oh,
Your
okay.
own ThinkPads.
Yeah,
I love my ThinkPad.
I've only used MacBooks for the past, 15 years or so. But anyway, just so everyone could have this. So they're selling bioreactors. Sophia was talking about Norwegian Cruise Lines being able to buy these notebooks. What I really liked Sophia talking about was the App Store. So you were just mentioning, different non-model organisms or different microbes being able to solve different problems, that there's a microbe for everything. So, there's an app for that, right? Similarly, there's a microbe for that. And to be able to use a carbon source, which is, life is carbon and oxygen and hydrogen. So to be able to use these waste gases with some other elements and minerals, perhaps, you can make stuff, you can make things. And I would love to see this in action. This is another one of those interviews where I was like, oh man, I wish we could take our cameras and go to the lab and see what they're making and be able to help people visualize how this works. Because there's, again, we were saying this on the top of the episode, there's nothing better than a demo for people to see what's actually going on. I mean, we have a podcast, our whole purpose is to talk. But now we have video, we can show things. And I think this is one of those great things to be able to show. You have these notebooks that are stacked, and being able to produce any type of product out of it it's very sci-fi becoming sci-fact.
Well, and the great thing for us is that Sophia's local. She's basically a train ride away, and we should just go over there and do some filming. Well, that's what our phones are for. We need to do this more often, or we need to start doing this so that our audience can see some of these companies that we're interviewing and what they're enabling.
Yeah. And just to give our listeners a reminder and a summary of how these bioreactors can work, what Sophia talked about was having these notebooks. She said that they could be at dairy farms or hog farms to get methane capture. So you have that feedstock to be able to make what you want. Wastewater treatment facilities, breweries, because they have 100% CO2 output. So any type of brewery. And we're thinking there's a lot of craft breweries here in Brooklyn alone. So what can that make locally for us, right? Of course, talk about breweries. Wineries also have seasonal CO2 waste. So how do you capture that? And to make things that complement those industries, like what could be made for wineries? I mean, I don't know if there's certain types of preservatives, or I don't know if they can make some type of paper for the label or the wax on the top of the bottle. I don't know. I mean, my mind's going wild here. And then, of course, you talk about landfills and how to take some gases from there to be able to produce anything. And that's really okay, if you're talking about landfills being a feedstock for making things, that's when you start achieving true circularity. And then we start eliminating this concept of waste and everything is being used for that whole abundance mentality to make whatever we need for everybody.
Yeah, I love that. I love what CarbonBridge is doing, and I agree. I think we need to have Sophia and Manu on here again soon, just to hear how they're evolving, particularly how their business model is evolving. I'm super excited for them, and I'm super glad we did that interview.
Yes, absolutely. Absolutely. So that's a wrap. I want to thank you so much for listening to the Grow Everything podcast. You can find us on all streaming channels. Of course, you found us on this streaming channel because you're listening to us right now, but there are others. So feel free to listen on other platforms. And guess what? We are very engaged with our audience. Text us, email us, call us. All information's in the show notes. We would love to hear from you. And of course, if you're viewing this on YouTube, hello, subscribe, like. We love engaging with our listeners. So thank you so much for listening to the Grow Everything podcast.
That's the pod.